This is the last lecture of our module on descriptive statistics. This is going to cover the topic of outliers. So what exactly is an outlier? Well, it's a value that's well separated from the majority of the observations. So I'll just go over to the document camera for a second. If I had a situation where, most of my data was here, then a value out here would be well separated from most of the cases and would be considered an outlier. So that's not a terribly precise definition of what an outlier is, but that's the gist of it. So what's the problem with an outlier? Well, outliers can exert a very strong influence on many statistics that we'll be looking at. So one example would be a graph, a histogram. If you had some outliers, if you had a very extreme outlier, what could happen with when you make a histogram is that all of the the majority of the data could be down here. And so there could be very interesting features down here, but that gets obscured because you have to allot an x-axis to be able to plot this point. All right, so that means that 99.9% of your data is sitting in a tiny sliver of the graph, and you're using the vast majority of your graph to show one value, and so you don't get to see the interesting features down here with the vast majority of the data. We've already seen how a single extreme value can distort a mean. You can inflate the mean to an arbitrarily large or small value by changing a single observation. It only gets worse when you deal with standard deviations, because standard deviations begin by squaring those deviations before taking the square root at the end. So an outlier can even distort that more. We'll be talking about regression estimates a little bit later on in this class and see that a single observation can really distort the slope or the intercept when we try to estimate a regression line. We're not going to talk about cluster analysis in this class, but cluster analysis and other machine learning methods can also be dominated by an outlier. All right, so that's why we care about outliers. How do we find them? Well, I said to start with, look at a box plot. Box plot is probably the place, the best graphical method for showing outliers, and as we saw before, with a box plot, for example, here's a nice box plot. Outliers are plotted outside of that, and so we could clearly see that there are three extreme values there. Sometimes if your data set's very large and you have a lot of outliers, you don't want to plot it. Something that I'll do is just compute the 99th percentile and compare it with the max. So if the 99th percentile is, say, 1,000, and your maximum value is 1,000,000, and this is, let's just assume some variable that only takes positive values, clearly that value 1,000,000 is well separated from 99% of the data and is an outlier. And you probably have some values between 1,000 and 1,000,000 that are also outliers. With that said, this is not the only consideration when detecting an outlier. So I'm going to sketch out kind of a famous example where the method I just described fails. Okay, so let's say that I have two variables, x and y, and perhaps I have a relationship that looks like this, and it looks really, very, very strong negative association between x and y. This value right here, I would say, is well separated from most of the data. So most of our data is sitting here, and then we have this value that's well separated from it. If I were to look at a box plot of x, well, this value would not be at all unusual, right? It would be not exactly in the middle of the distribution, but certainly not extreme. Likewise, if I looked at a box plot of y, this value would be not separated. Not, you know, the box plots for this would look perfectly normal, and you wouldn't be able to detect that. Now, of course, you could draw a scatter plot in this case and see it, but things get trickier if you had very high dimensions. So if I were out in 10-dimensional space, it would be much more difficult to see a point that's well separated from the main cluster of observations. So just looking at a box plot doesn't do everything for us. All right, how do we what do we do when we have outliers? So the answer is you need to first answer this question: why is a value an outlier? And there's really two possible answers to this question. So the first answer is the value is a mistake. So I call this the erroneous value answer. And so things happen with data transfers, they can be corrupted. If people are typing in values, people make mistakes when they type. Sometimes you get people who intentionally try to sabotage a survey, for example, by giving you weird numbers. So those would all be examples of erroneous values. When you do this, you have you either fix it, so go get the correct data. So if there was a data transmission error, get them to retransmit the data, or set them to missing. There's a very famous video from Wendy's, and I encourage you to watch that on your own. I call this video the birth of an outlier. Basically what happens in this video, you have a car at a drive-through window at Wendy's, and the car picks up its food and leaves, and then the person working behind the counter swings a metal bucket over the ground and brings it back in the window. And the question is, what's happening there? And the answer is that person's probably being compensated by the number of cars that are passing through the drive-through window. And the easiest way to increase that count is to swing the metal bucket, which sets off the metal detector, that's going to create an outlier. All right, so in that case, you'd want to try to get clean data by looking at cash register receipts for that person working behind the window, something like that. So erroneous value is one possible answer. And the other possible answer is it's a correct but extreme value. If we have a population of people and there's some billionaires in there, the billionaires would really have very large incomes and would be well separated from most of the distribution. But those are correct values. They're just extreme. So what do you do? So there's not a simple answer to the correct but extreme value case. Sometimes the observations are just from different populations. So I give an example of a company that sells things to consumers as well as to businesses. And the businesses tend to place really big orders. The consumers place small orders. And the businesses are few. The business customers are few in number, and therefore they look like outliers. But if you think about it, the businesses are really just a different segment of customers. They probably have very different needs. And so what you could do is separate the business customers from the consumer customers, and then the business values are no longer outliers, because among the businesses, all the values tend to be large. Another approach is to use what are called robust statistics. So we've already met several robust statistics in this class. We've met things like the median, the trimmed mean, the interquartile range. These are all values that are robust to outliers, in that you can't change the statistic drastically by changing the value of one or two observations as you can with the mean or regression coefficient. There are other versions of, for example, regression analysis that you will run into at some point if you take more statistics that are robust regression methods. So that's another approach. I'll just mention the main advantage to a robust statistic. I guess that you could say it's one of the main advantages is you get to maintain the original units. So medians are measured in the same units as the variable. All right, so that's a desirable thing. Trimmed means are in the original units. Another approach is to transform the variable. So the most common transformations are logs or square roots. So just as a quick example, if you go to the next page, you're going to be doing a lot with this data set on your homework, but this is the fitness club example, and I've generated a histogram of the down payment amount. And so the down payment amounts have a very vast range from about $0 to $10,000. This was a 3-year health club membership. Let me know if you'd be willing to spend $10,000 on a 3-year health club membership. It seems a bit pricey. So there must be something wrong with these values out here. Notice that what we're, the vast majority of our cases are squeezed into one bar. So here we see exactly what I was talking about earlier with outliers dominating a graph. So a way that makes sense in this case is to, for example, take logs. So here's the same graph with applying the base 10 logarithm to it first. I'll mention how you do this in R. You can just add the log function to the histogram command, and it works. All right. When should you take logs? Well, in some instances, log units are more natural. So there are many scales that get used across many different fields. So for example, the Richter scale measures damage from an earthquake, and that is really a log scale. If you've done any astronomy, star intensities are also measured on log scales. Basically, anytime you have exponential growth, you're much better off using a log scale. I just put a little bit about exponential growth. Here's exponential growth. When you log it, you get a linear scale. So right now, we're in the middle of the coronavirus, and this is a very famous graph that's making its way around a lot of different newspapers right now. And this is on a log scale. The reason for this is the way viruses spread, is geometrically or exponentially. And so a line on this plot means that you're getting this exponential growth. For example, any country that had this slope would be doubling every day. So it'd be like a base 2 log with a coefficient of 1. Here you're doubling every other day, every 3 days. All right, so in that instance, it makes a lot more sense to plot it on a log scale, and I never thought I'd see a log scale in the popular press, but we are seeing it. So those are some basic ways of dealing with outliers. Your homework is going to be to analyze that fitness club data set, and there are a lot of issues for you to find, including these outliers. And you're going to have to think through what are you going to do about them. Okay, that's it for outliers.